Welcome to my YouTube channel Manoj Networking, and here I'll be mainly discussing about the network related concepts and the technologies. And as part of our learning series, today we'll see about what is this VLAN and a broadcast domain. So basically this is an extended session of my previous class. So I have already discussed in my previous video about what is a broadcast domain and how we can configure the VLAN. So if any of you missed my previous class, so I suggest and recommend to please go and watch that video first, and then please watch this one so that you can easily follow what's going on. And I have used this lab to demonstrate about the VLAN and the broadcast domain. So now let's see a couple of theory in related to VLAN. So basically VLAN stands for virtual LAN, and it's a layer 2 switching technology. So it will provide layer 2 security. So it enables group of devices available in multiple networks to be combined into one logical network. This is very important. So VLAN makes your network logically segregated into different VLANs. So without VLAN, a broadcast sent from a host can easily reach all the network devices, and each and every device will process broadcast received frames. So it can increase CPU overhead, and on each device, and reduce the overall network security. And so to understand easily about this broadcast domain, let me tell you one more example. Like let's say I have created one WhatsApp group. With I am the admin. So I have added 10 students, for example. So in the WhatsApp group I have created 10 users and me as an admin. So like let's say I am talking to, for example, Ajay. Okay, so we both are talking, but we are doing the conversation on the WhatsApp group. So even though now myself and Ajay are talking, all the remaining 10 people, 9 students in my WhatsApp group, they are listening unnecessarily. So basically they don't want that information, but still they are receiving that information. The same way will happen for our switches also. So the broadcast domain, basically it will roll over to all the switches. So like let's say you have 4 switches that are connected. So from this is your PC1, and this is, for example, PC2. So even though since they are connected, so once the broadcast packet came to PC1, so it will send to switch, and this switch will send to this switch, this will send to this one, and here to here, and finally to n number of switches. So that's the problem with your broadcast domains. So that's the reason. So without VLANs, a broadcast room sent from a host can easily reach all the network devices. So and that will increase your CPU overhead and memory related issues. So that will breach your network security also. So in case if you place interfaces on both switches into separate VLAN, a broadcast domain from host A can reach only devices available in the same VLAN. Hosts of VLAN will not even aware of that communication took place. That means it is very important. Like let's say you have created VLAN A and VLAN B. So now if you have grouped 10 devices in VLAN A, only that 10 devices can go on talk. If you have segregated 10 devices in VLAN B, only that devices will go on talk. The same example I have showcased here. So two computers, PC0, PC1 are from VLAN 10. So PC2 and PC3 are from VLAN 20. So now 1.1 we can go on talk to 1.1, can go on talk to 1.2, and 1.3, that is possible, can go on talk to 1.4. Like let's say we have one more PC5, and I'll place that interface into VLAN 20. So now this PC2 can talk to PC5, this PC3 can talk to PC5. Okay, so actually there is no limit. We can connect n number of n devices in a single VLAN. Now if you see, all these 4 computers are placed in VLAN 10. Now all of these people can go on talk with any of them. But if this 1.1 wanted to talk to 1.3, this is not possible. This is not possible, but that is possible through inter VLAN routing. But since we are learning about VLAN, so basically VLAN means, so the switch does not allow VLAN propagations from one VLAN to other VLAN. That is not possible. Okay, and as I said, you can create a number of VLANs. Like let's say here we can create VLAN 30, and for this here also we can assign multiple computers. Okay, so based on your requirements we can create n number of VLANs, and that is possible. Okay, so moving further with the theory, so this is how a broadcast domain will be looking like. The left side is the one that you are seeing without, it's a single broadcast domain. It's a single broadcast domain. If you see, all the accounts team, marketing, all the accounts team, marketing team, sales team, finance team, even though they are from different subnets, but still they are all connected to single switch, single broadcast domain. This is very important. They all are from single broadcast domain. So that's why once the frame will reach to this switch, it will propagate to all the other switches, switch 5. So this switch also will receive, switch 6 also will receive, and so on. But if you see, this is the segregated topology. This is the segregated topology in VLAN. So now, like let's say for VLAN accounts, we have created VLAN 10. So now in marketing we have created VLAN 20, sales for VLAN 30, finance for VLAN 40. Now these three computers in finance, they can talk. These three computers in account, they can talk, but cross talking is not allowed. Like let's say if this marketing wanted to talk to sales, that is not allowed. So now basically limit the number of broadcasts, better performance and security. That is the advantages you will get with your VLAN architecture. So we'll see the couple of advantages in using the VLANs. So benefits of VLANs. So actually it will solve your main problem of your broadcast. So switch is a device that will allow the broadcast. So VLAN reduces the broadcast domains, and VLAN provides increased performance. It provides latency. It removes the physical boundary. That's true. So it lets you to easily segment your network. Yes. So VLAN makes managing physical devices less complex. Separated, you can keep hosts separated by VLAN. There are so many benefits of VLAN, so please go through that. So moving further, we'll see range of VLANs. So this is very important to understand what is the range of VLANs. So there should be some limited factor, right? I mean, we will not be able to create 10,000 VLAN, 20,000 VLAN. There should be some limiting factor. Okay, so that's where we'll define the range of VLANs. Okay, and so if you see VLAN 1 is the default VLAN. This is very important. So by default all the switch ports will come in VLAN 1. So if it is a 24 port switch or if it is a 48 port switch, all the VLANs by default it will come with VLAN 1. So it's not possible to delete or edit this VLAN, but we can use it. Okay, and it's recommended for your production networks, please don't use any VLAN 1. And from VLAN 2 to 1001, it's a normal VLAN range. We can create it, we can edit it, and we also can delete it. And from 1002 to 1005, again these are Cisco default. For token rings and FTDA, you will not be able to delete these VLANs as well. And from 1006 to 4094, again these are extended range of VLANs, but if we can use it for normal operations, and it's recommended we can use those VLANs without any problem. So let me jump on to the Cisco packet tracer to see that to see that demonstration. So now show VLAN brief to see the ports. So as I said, by default all the switch ports will come in VLAN 1, and you can see here I have created 3 VLANs, 10, 20 and 30. Again you are seeing from 1002 to 1005, these are Cisco default ones, and again this is not possible to delete and modify anything. So here we can create a number of VLANs, like let's say if you wanted to create VLAN 50, or as I said, you can even put question mark. Now if you see, it's asking, so we can put number 50, name is for example finance, and the changes are immediate. So if I ask show do VLAN, so it will say 50 finance and it will be active. Okay, so that's all for this video.